Hi, this is Nate Peterson from Group 5. This week we're presenting on Chapter 23, Protecting the Deployment Pipeline. And in this chapter, we discuss integrating security and compliance into the change approval process, recategorize the majority of our lower-risk changes as standard changes, and what to do when changes are categorized as normal changes, reducing reliance on separation of duty, and ensuring documentation and proof for auditors and compliance officers. Integrate security and compliance into the change approval process. The changes in the approval process are defined in three ways. The first way are defined as standard changes. These are lower risk changes that follow an established and approved process, but can also be pre-approved. The second change is normal changes. These are higher risk changes that require review or approval from the agreed upon change authority. The third is urgent change. These are emergency and high risk changes that must be put into production immediately. They often require senior management approval, but allow documentation to be performed after the fact. Recategorize the majority of our lower risk changes as standard changes. This demonstrates changes to be low risk and allows them to deploy without further approval. It supports low risk assertion by showing a history of changes and records all the changes for visibility. It makes it possible to automatically link these change request records to specific items in our work planning tools for context and traceability. It also makes it possible to find balance for details and traceability as to not be too time-consuming. What to do when changes are categorized as normal changes. Our goal in this case is to ensure that we can deploy quickly, even if it is not fully automated. We can automate the creation of complete and accurate RFCs, requests for change, populating the ticket with details of exactly what is to be changed. We share evidence that the change will operate as designed, and provide machine-readable data for integrations and make a track record of successful automated changes for eventual classification of standard changes. Around 2007, Salesforce.com found themselves unable to provide more than one release to their customers per year. Despite hiring additional engineers, their output kept decreasing. Due to these issues, 2007 marked the last year that Salesforce developed and released software using a waterfall process. Starting in 2009, Salesforce started on a multi-year DevOps transformation. By implementing these DevOps strategies, the company reduced their deployment lead times from 6 days to 5 minutes by 2013. In this transformation, the main theme was to make quality engineering everyone's job, regardless of the role in the value stream. They also implemented destructive testing to continually test the integrity of their systems. In the end, they had not only integrated their DevOps with their change management process, but also created motivation to make all these changes company-wide. Reduce reliance on separation of duty. Separation of duty can slow down the ability to deploy frequently. There are 3 practices to consider. These include pair program, continuous inspection, and code review. These 3 controls give us the necessary reassurance about the quality of our work, and we can show that we achieve equivalent outcomes with the controls we have created. Bill Massey is a development manager at Etsy who is also responsible for their internal payment processing application called ICHT. Because ICHT is the application that accepted customer payments, it is subject to the Payment Card Industry Data Security Standards, or PCI DSS. In order to comply with the PCI DSS scope, the ICHT application is physically and logically separated from the rest of the Etsy organization, with its own team of developers, DBAs, network engineers, and operations staff. The ICHT team had to modify their continuous delivery practices in order to accommodate the need for code approvals according to the PCI DSS. Massey was then designated as the change approver responsible for deploying changes into production. The troubling side effect of this process is that there is too much compartmentalization of the ICHT team that no other Etsy group has. In essence, no one on the ICHT team has the ability to be a full-stack engineer. This shows us that even with all the advantages of a DevOps environment, there is still an element of fragility. Even a team that has a high trust and shared goals can begin to struggle when low trust control mechanisms are put in place. Ensure documentation and proof for auditors and compliance officers. There are huge gaps of knowledge between auditors and developers. These gaps integrate auditors and control design processes. It is important to send all data to telemetry for auditors to access. This also helps auditors to translate and recognize data. Bill Shin is a principal security solutions architect at Amazon Web Services. He has helped many enterprise customers who use public clouds in highly regulated environments. Shin notes that there is a large disparity between IT auditors and DevOps work patterns because most auditors have been trained to work more with physical environments rather than code-based environments. When modern audit logging, chat rooms, and deployment pipelines, there's an abundance of transparency into what's happening in the production system. The challenge is to turn all that evidence into something that an auditor can understand and recognize. This requires deriving the engineering requirements from the actual compliance regulations. How to fulfill that requirement is a discussion that needs to happen between compliance and regulatory officers and the security and DevOps teams, specifically around problem detection, prevention, and correction. To help solve this problem, the DevOps Audit Defense Toolkit describes the end-to-end narrative of the compliance and audit process for an organization. This document describes how controls could be designed in a deployment pipeline to mitigate the stated risks and provide examples of how to demonstrate control effectiveness. Additionally, Mary Smith, a pseudonym, heads up the DevOps initiative for the consumer banking entity of a large financial services company. She observes that the audit and compliance officers put too much reliance on code reviews to detect fraud. She recalls that they once had a developer who had planted a backdoor in the code that runs their ATM systems that put an ATM in maintenance mode, allowing them to take cash out of the machines. They were able to detect the fraud quickly, but it wasn't through a code review. This fraud occurred despite the separation of duties between DevOps and the change approval process, but was quickly detected and corrected through effective production telemetry. In conclusion, we have discussed practices that make information security everyone's job. This improves effectiveness of controls, better prevents security breaches, detects breaches faster, and recovers from breaches faster, and significantly reduces the work with passing security audits. Thanks very much for listening.